Hey, what's going on, everyone? I wanted to do a quick video for you guys, show you a little something that I've been working on. A couple of the guys that I know, I kind of talk about this a lot, but I've been building an application for something that feel there is an opportunity for a solution. So part of that is, you know, getting into having to develop an architecture that supports what I am trying to get after. And I've learned a lot on this journey. I got halfway in my mind and completely had to start from scratch just from the amount of stuff that you need to learn. That I learned along the way that I'm going to say you need to learn, but it's good to know that it'll help prevent a lot of issues in the future. In the future, as the application or whatever you're building start getting more success, and failures and downtimes really aren't a tolerable event. So that's why I'm kind of really getting it hard now, as far as learning the theories and architectures and design patterns and methodologies and idioms and all that good stuff. I'm gonna say the hard way, but just learning it so I can build it in the way that I want to build it. So anyway, part of that is going from the idea of what I thought to build a software was the most efficient way in my mind. I thought was come to find out the term that they use for is a monolithic approach, which means that you have a bunch of classes and services in tied together within the same system, and that whole system works as a single application. So if something fails in that monolithic application, the entire application fails. But it is more, I would say, the fastest way for execution, just based off of stuff that I've come across as I'm learning this stuff. But um, anyway, that's how I was building it at first, and till I came to realize that I wasn't really making a lot of progress because the monolithic approach it really requires a lot of planning. Big architectures require planning, but the monolithic approach really does, because you have to think about all the little moving pieces and parts that may affect this thing and something else. And so there's so many different variables that go into your application that you might get halfway building a module and then come to find out that, oh crap, you really don't need that. You need that module to access another piece of data. So what do you go to do another design pattern to make that happen, or do you manipulate what you already have going to incorporate that new piece of data? But now you have to kind of change the architecture in order for that to be supported. So that's some of the things that I kind of ran into in the way that in my path of developing. But anyway, what I ended up going with is a microservice approach. And what a microservice is it's taking up chunks or functionality of your application, of your overall application, and breaking it up into many services. And then on top of that service, you build some kind of an interface that other services or users can actually access to get data or perform actions or whatever the case is. So in this particular case, and I'll just give you guys a quick diagram of what that looks like. Here's a user that would go into the front end, which would be the website or the web page of whatever my application would be hosting, HTML or whatever. And on the front end, it'll have communication with other services that I have instantiated. So in this particular case, I have a database. And actually, let me draw a line between that because they communicate as well. I have a database, and then I have my Node API. So the front end will be pulling information from the Node API service and pulling information for the database to either build the web page or perform a function based off of what the user has inputted onto the web page. So you can get a lot of flexibility. With this architecture, what this really does is helps you with is that now each service is an independent module, meaning that it can actually be written in a whole different language if you need it to be, depending on whatever the use case of that service is going to be. So now, this in this particular case, this is kind of my situation. My database is actually CouchDB, and I use Couch because it has a RESTful interface natively, so you can do HTTP calls. So it's just really easy to deal with because it's all HTTP requests to an API that gives you access to the database. So I use Couch for that purpose there, and my Node API, which I built using Python Flask. But if I wanted to, I could have built that in Go. I could build it in whatever language I want, but I just have to build a RESTful interface for that application to access. And then same thing with the front end. The front end can be a Node.js, or it could just be a native JavaScript or jQuery, or Vagrant, I believe, is another framework for front end interfaces. But that's just the overall of what a microservice is. So it's something really cool that I started to learn about and started to really embrace, and seeing the flexibility based off of the type of application that I plan on doing, which is an auditing application. So it it allows me to have a lot more flexibility and features in what I want to offer, and then control those features a lot more tightly. So, like in this particular case, I needed a Node API, and the specific purpose for that API is to do all things that have to do with dealing with nodes in the database, which a node would eventually be a target within my application when the auditing is happening. But I needed something that no matter what, I can always pull nodes, get nodes, add nodes, delete nodes, modify nodes, do scans directly from this API. So, like I said, I wrote that in Python. So this is the management interface. It's not anything beautiful yet, but this is the management interface. And on load, what it does is it actually reaches into my database and loads the devices in there. And then based off of that, I can view the information. I didn't really create a beautiful page for this. I have a JSON parser, and I like looking at the data like this anyway. So you can go through and look at the data structure for that particular node to get more information on it. And also, you can add a node here directly from the console as well. So just add a node real quick. I just drop down, just call this router, and you can see it's there, and I can delete a node. So on the back end, what you don't see is what's happening here is I have the server running on a different host in my network. So I'm actually using DNS and then getting to my that service this way. But what's happening on the back end of this front end, like I said in this diagram, is that this URL, the front end is actually making calls to the database, well, really to the Node API, who's then reaching into the database. The front end, if I take this out, you could have it reach into it, but the front end is typically just going to reach into the API. And so this is just the management interface in this case. That's how I designed this. The front end is actually not talking to the database with the way I have this working. Um, but yeah, but through the API, I'm actually extracting the node information. Now, another cool thing that I added, and just another feature I wanted to show you guys, is that I added a subnet scan feature because I wanted to be able to, when I add a node, or if when a client customer wants to when a client wants to use the application and say that they don't want to go through and manually enter, 100 and something IP addresses or 1,000 plus IP addresses, because the application requirement for mine is just SSH and SNMP. I'm gonna do a port knock or a port scan on those two ports, and if those are open based off of a service discovery, then I'll say that they're active hosts. So with my subnet scan, I actually created a subnet scan controller endpoint on the API, and I'll show you guys how that works. So what ends up happening here is that I have a flag called auto add, so I can just do discovery just to see what's on the network and not actually add it to the database. And by default, this auto add flag is false, but if I set it to true, what'll happen is it'll go through and add those devices that it did find onto the database. So let me just go through and do a smaller subnet here. Do a send. And as you can see, it went ahead and added it. So it the way the uniqueness is checked inside the application as well, because I do have validation going on, is that it checks by the IP address. So in this particular case, 409 is a conflict response code. So what ends up happening is that I'll get the message back. It'll give me the first half of the results is going to be whether the node posted or not. So if I get a 409, that means it didn't. If I get a 201, that means it's created. 201, that means it's created. And then based off of that, when I do the port scan, it'll tell me what ports came back as false or active or not active, which is what's indicated by true and false. And then because I did the scan based off of this, and this is just my home subnet, I just go through and I can go back to the database here or to the front end, and I just reload the page. and then you'll see that the IPs that it scanned automatically added it to the database. And with form validation, I can also make sure that I didn't make any mistakes or none of my data gets corrupted on input, because that's very important, in particularly what I'll be dealing with for integrity purposes. So, um, yeah, this is just a basic microservice, or just a little component of the larger application that I'm working on. I just wanted to show you guys just some of the cool things that I'm learning as I'm going through this world of software development. All right, well, if you guys have any other questions, drop a comment and I'll be happy to answer. Peace.